I'm not sure if you guys are familiar with maps like these. I really like them a lot, elevation maps. I look at them every day, all day if I can. So topography does give us a lot of opportunities in terms of networks we're building, radio systems we're building. It gives us free elevation. If you're in a very good spot like this one, you can actually have a very small little tower that gives you great coverage because the mountain itself is already about 1 kilometer high. If you look very well, you can actually see Jeff here, my colleague, chilling on the mountain as well. Yeah, so topography does give us a lot of opportunities. There's also opportunities like this one, looking at that same hill. If you look at the simulations we're doing, you see that on the right, it's a very small tower, but you still have a lot of elevation because the mountain or the topography is very high. Great topography can enable great networks. Some parks you arrive in, some parks are perfect for radio technology, for LoRa networks. Other parks are a complete nightmare. And this is again Liwonde, which has a huge flat areas, but then other than that, also really high points. So it's, for us, a really easy and nice park to build a really nice network, because you don't need high towers, you don't need big infrastructure, but you can still reach all the corners of the park. This is one of the challenges we have in topography, because if you decide to build your stuff on top of a copy, you also need to get stuff there. So yeah, sometimes you have to climb a lot, which I also like, so that's really good. But you can imagine if you're carrying 60 kilo Victron batteries to the top of these hills, it's a different mission. So definitely a challenge. There are sites, for instance, that you can only get to with a helicopter. That becomes problematic in terms of maintenance, because if your helicopter doesn't work, your network doesn't work if something goes wrong. So there's lots to think about when you have topography and when you start building these kind of networks. Shading is obvious. It's an obvious problem for everyone that does anything with LoRa or radio technology. This is the same hill again in Liwonde. And you can see for our LoRa system simulation-wise, that hill is a huge opportunity, but also a big challenge, because it means that you're creating big shades on the other side of the hill. And then there's obviously the facts that you don't see. So basically, in Google Earth, after doing all the simulations, this is what you see. When you get to the site, there seems to be a rock there. So the ground truthing of everything we do is one of the most important things, but it's also usually one of the most difficult things. And Rian and Sean will also talk about that in a bit. Yeah, so presentation-wise, we're going to keep it very short because we thought hopefully you're going to have a lot of questions for us. We're going to start with a couple of prepared questions to get going, and then we can hopefully go to you. This is in Nyungwe, by the way, in Rwanda. Another great spot to have a network, but it's the tropical rainforest, so you do have to think about that. What are you going to do with the network? Because radio-wise, it's a challenge. All right, so the first question we've actually prepared is for Rian. I'll read it out, and then you already have a microphone, I believe. We've spoken about the impact that topography has on the planning and deployment of networks, but to what extent does seasonal topology changes play a role?
Topography does not only impact the network design. It also impacts the remote sensing design, the choice of technologies. I mean, if we have a look, and I don't see the guys from the Delta here, but if you have a look at Delta, for instance, you've got an ever-changing topography because of the flooding and receding of water. So it's not only about hills and those type of things. You actually need to keep in mind that, you know, so if you've got a flood, your habitat changes. So what you want to measure changes. And if you've got, for instance, if you're looking at anti-poaching, a entry and exit route also changes. So what you need to do when you look at your designs is look at the network design for coverage, but also look at data sourcing for that, you know, how topography plays a role in that. And that's going to drive decisions with regards to technology choices, for instance. Right, so it's not going to be a one fit for all. And you hear this message coming from me quite often, that we can do planning, desktop planning, as much as we want. We are fully dependent on the boots on the ground to be part and parcel of the design process.
Yeah, okay. Adding to that, as a commercial company, having done this for 10 years, I would say it's impossible to do this as a commercial company, delivering communications and technology on the ground without full engagement with the end user. Meaning that I'm not a supplier and you're not a customer. The only way you can do this is in compliance with the supplier that you're working with. Whoever the supplier is, whatever the technology is, if you, whilst they're doing the planning, assume that you're paying them, so they're going to come and do a good job. If you don't lend 100% of your time to topology, you'll fail. Because it's nigh on impossible to work across the continent of Africa and Asia without your framework when you're building topology. Because the tools are only as good as the sites behind them, but it's on boots on the ground, which is everything for anyone delivering topology in conservation.
Yeah, thank you. I mean, we can, because you're both broken already, if anyone already has a follow-up question in this regard, or not yet?
Sean, what do you mean by full engagement? Like, what are you looking for from a client site to meet you more halfway?
Basically, be part of the whole planning phase. So don't assume that, so for example, we've probably done one recce, and that was actually last week with Morris, actually, because people can't afford it. So for us to fly out and then bounce around the whole conservation park, flights, wages, that's a lot of money, okay? And people are always struggling with training and support of infrastructure, so they just don't have the budget for a recce. So to really do a good topology piece of work, you need a recce. So we can't do recces because there isn't a budget for recces. So you do the recce with us, you help us. So we know from, like you say, you do your link budgets and you do your RF planning, but when we get there is no power. Well, you didn't tell us there was no power, so now we have to factor in power. So those things, we need full engagement throughout the whole process, what you've got, which is why we have a Q&A documentation. We need all those bits before we can even go forward. If you turn up having done planning with no full engagement, and you turn up and there's no roads, there's no power, then you just spent money on equipment that isn't going to work. So that's what I mean by full engagement.
And in that, you know, you have to pretty much sometimes set up a system to also check on people, because the knowledge on the ground is also sometimes lacking, and people don't always realize how important it is to put a tower there for your system. There are examples where people have put a tower 8 kilometers from the point because they might thought it was a better position. So you need to, you need to constantly check, but also, like from our side, also again, training a lot of the people in the field to also understand what we are looking at and what we need to know. And from our side, we also try and always confirm everything with pictures. Because in the past, it has been like, is everything ready? You get a proper yes. Okay, we're coming next week. You get there, there is no tower. Yeah, but it's in the workshop, right? So there's also an understanding of what is ready. Like all of these things play a big role in any of these things.
Believe it or not, that happens quite a lot. You'll turn up and the tower's not there. So trust me, we really need to know everything because we turn up with £100,000 worth of radios and the Rangers are ready and there's no tower, or power or roof on the upstream. So we need those answers.
Or you have red t-shirts and red boots and everything after the first day because the paint is still done this morning. Should we go to the second question from our side? Or if you guys have anything to ask already, we can always do that. So how do I get hold of topography planning tools, Sean, to train my staff?
Well, we've got some guys at the back which will happily show you the RF planning tools. So what we do, because we do radios and ops rooms, and we leave the IoT stuff to people at Smart. So collaboration is everything. So when it comes to the radio stuff, you can buy your own license, and we'll happily show you at the back of the room later on. It's called RF planning, very simple to use. You get tokens, You open it up, you log in, you pinpoint where you want your tower, you put the height, and it will then give you the spread of what the RF plan will look like. And then you just raise the height of the tower or the height of the power, and then it just simply gives you the map spread of where the communications will work for RF. So for RF planning, that's what we use, an RF planning tool. There's many out there. When it comes to SATCOMs, obviously, the only time you're going to get good SATCOMs is when you're not in the jungle, so that's pretty easy to plan for SATCOMs. LoRaWAN does the same as RF in effect. Still RF planning tools, very, very simple to use. And actually, if you come to any supplier and say, right, this is where we're going to put the tower, we've already done the RF planning, and this is where we see an issue, so can you work with us here? You'll save yourself a lot of heartache, and the suppliers you're working with will realise that you know what you're doing. If they know you know what you're doing, then you'll get treated differently, and then you won't get ripped off, which is what it is.
Yeah, if I can quickly add there, I mean, as Sean said, there's a lot of RF planning tools out there. Any radio provider actually gives you an RF planning tool. I think some of the key things that you need to keep in mind is when you look at planning for a specific technology, understand the frequency of the technology that you're working with, because if it says radio frequency, there's different frequencies that's got different patterns, different spreads, and all those type of things that come into play. I mean, I'm not going to go into too much detail here, but I just want to flag that. And I also want to add to what Sean said with regards to doing the RF planning yourself, because the tool is good, but it's not perfect. None of these tools are perfect, and that's why we call it the desktop study. So there is a lot of value in you that's on.
We've been trying to do more of the planning ourselves, mainly just because of the limitations that are not necessarily visual in the actual planning tool. So for example, we might have a perfect mountain, but if you put in infrastructure there, it's going to slow down in a week. So unfortunately, you take that out of your plan, and so sort of the conversation goes round and round and round. And I think that, like, as you guys said, like, if you can move some of that to the actual site that has the on-the-ground knowledge, it's really great. And what I think some of the, and I have to put my hand up here myself, is that we lack some of the more, the tweaks to some of these planning tools in terms of like loss, how long.
If you're looking at clearance, what should that clearance look like? Can you really push it? So that the tool gives you a 99.95, or should you be going for 99.99? So it's actually a great idea to put some best case principles down. I 100%. I mean, so thanks for that. The sensor height is extremely important because I mean I can call out a use case. We deployed a LoRaWAN network in South Africa, and part and parcel of what we as CCF are doing is we're actually doing a bit of work to allow us to actually monitor the coverage that we're really getting, so that we can overlay it over on top of tools, so that we can actually come back with lessons learned of this tool is this accurate, that tool is this accurate. Obviously, it's going to be based on topology and that type of thing. Unfortunately, one of the reserves that we help with LoRa technology decided to take one of the trackers that we expected to be on humans and put it on a helicopter. So suddenly my coverage map, I got 130 kilometers coverage on LoRa. And it was quite strange, and then I realized that it was on a helicopter. So very absolutely valid point. Understand where the connection between the 2 points, so that your line of sight design is right. The other thing is topology is you have to balance the visual impact of the technology you put in, the market you put in, with what the reserve or the protected area wants to protect. I'm busy with another project in Botswana at this stage, and quite frankly, because of the visual impact in the terrain, I had to go for tall masts. I mean, I'm talking 39 meters, but what I did was I pushed it to the perimeter. So you don't have an impact in the middle of the protected area, but I had to go wide and go with high mast. So there's a lot of soft things as well to keep in mind when you do these designs.
And thank you for your point, Swabi. Just to get a little bit back on that, what we also always try to do is have the minimum, right? Because if you look at, in terms of AP, if I promise my managers, we're going to have a radio system there, they're going to want it, right? So what we are trying to do is definitely not overpromise, because then you will get into problem. If you underpromise and it seems to work 2 kilometers or 3 kilometers further, then everyone's really happy. So you do have to balance also, and it sounds stupid, but you got to balance what people want out of the system. Expectation management is huge, because if you make the expectations higher than it's going to be in reality, it's always going to give problems, from what I have seen personally. Any other questions already from Durham? You talking about a network link or radios or whatever? Yeah, so I mean, flat areas are always a nightmare in the sense that you will need more towers or very high towers to get the same result, right? If you look at network links, you can usually get, much shorter distances when an area is flat. Because then it depends on the height of the tower to be able to get the Fresnel zone through the bush. And there are people that can build incredibly high towers, but then the question about cost, maintenance, and all of that stuff also comes into play.
Yeah, and there's, so can I start with a question first? It's very important to know what you're trying to achieve. Are you trying to create coverage for sensor data? Are you trying to create coverage for handheld radios? Or are you trying to interconnect things? Or are you trying to create coverage for something that needs relatively high bandwidth, but is going to be mobile to some extent? Or create coverage such as 5G, which is completely mobile. So yeah, I think it's important to understand what it is, the kind of data you're trying to collect, or what are you trying to achieve with that. And that's very important. Something else to keep in mind is when you have a look at the height of your masts, you need to keep regulations in mind as well, because different countries have got different regulations. I mean, for instance, if I have a look in South Africa, where we do a lot of work, we usually aim for 15-meter towers maximum. As soon as you go beyond 39 meters, you need to have those little red lights on top of it, and you need to do an environmental impact study, which that costs money. All right, so those are the kind of questions or things you also need to keep in mind when you do your designs and when you want to deploy.
Just another point on the towers, which we've been caught out loads of times. Someone will say there's a 30-meter tower, and you get there, and actually the top of the tower is already loaded with other antennas, because the top of the antenna is the highest commodity, obviously, in comms. So you get there, and now the expectations are in the toilet, because you're only now to use the center of the tower. But the center of the tower is a different thickness to the top. So now you've got the wrong connectors to put the antennas on the tower, right? So all of a sudden now, you've got a comm system you can't put together because you've been told you're at the top of the tower, you get there, and it's already full up. So now you're in the middle of the tower. So now you've decreased by 50% your topology, and you can't even put it on because the tower thickness is different. So these are the sort of things you have to worry about and think about when you're actually thinking about what you're going to do to that tower, where you're putting the antennas on and why. So that's very important to think about.
And those are the things that do happen all the time, right? I mean, if you've also worked with telco towers, trying to explain parts that when towers are not straight, then you have to have a mount to make that straight, right? So if your tower is going up like that, then you need to have something to make that nice and level again. And yeah, otherwise it's also going to have a big impact on your system. More questions? I've got some. We got that one. So what are your thoughts on mitigating the discussed topography challenges? I think we've done that a little bit already. Let's go to the, oh, we've got one answer.
I'll add something to that. Don't trust just one tool. If you're doing planning, have a look at the same topography from different tools, right? Because one area, the one tool might be slightly more accurate than the other one. So you're getting a bit of a feel of you know, the average between the tools. But again, that's the desktop planning. The true feeling is first of the guys on the floor, and then a recce, because a recce is pretty much it should be a validation. That's also how you optimize that cost. But please, you know, look at multiple tools. I mean, if I have a look from my point of view, my experience just using free tools. If you want to have a look at elevation, identifying elevation, Google Maps is the best to go from a free tool point of view. If you actually want to have a look at earth curvature and that type of thing, I make use of another supplier's tool. I'm not going to call the supplier out, but their curvature and fractional zone kind of calculations is quite good. And then Google Earth I'll use just to validate some of the spreading factor that I'm seeing. From the supplier tool, I'll have a look at what the view shed in Google Earth is. You know, just do a bit of a litmus test. So take away, don't just trust one tool. There's many tools that's free out there. Yeah, get a good feel for it.
And yeah, you base yourself on the tools that use the different elevation models. Because that was actually the example that Arit wanted to tell us here. Was that they did all the calculations, everything was done, they used a couple of tools, I believe. They got there, they got on top of the mountain where they wanted to install the things, and like a kilometer from that mountain was a huge granite copy that was on no map. You can see it on the picture, but it wasn't on the elevation map. And then afterwards they did realize, but it was apparently on the EarthRanger 3D map. So apparently that then uses a different model maybe, so it was there, but it wasn't on the maps for the simulations. And that will surprise you when you, especially if you've already done the concrete and the tower is there, and you get there and there's just a big mountain in a way, so that's obviously problematic. Well, you wouldn't really want it there. I mean, the only place I've been through that is in Akagera, where people did think the towers were ugly, but we managed to turn that around and say, but this way you can actually explain the people that are visiting how you manage your part. Communication is key, and yeah, as you know, from our side, we're not hiding any towers anymore.
It's actually interesting. I mean, our experience, the best way to camouflage a tower is to galvanize it and leave it to weather. Because if you look at a galvanized tower, standing a distance away, it actually blends into the skyline. So you don't see it. You only see it when you're close to it. With regards to camouflaging, putting trees and branches, that type of thing, quite frankly, never been exposed to that. If you go from a pure technology point of view, you shouldn't have any influence, because most of the technologies have got some sort of beam forming, so you know, some shape that it pushes out. If you have a look at something like LoRa and that type of thing, that's typically sitting quite high up. That's got omnidirectional, but it's got a very, very low frequency, so it does penetrate quite well. But quite frankly, never been exposed to anybody actually camouflaging with.
And another fun fact, when I started working in ecology, I never saw any towers. In the Kruger and all these places, I never saw any towers. I started doing towers in Akagera, and after that you visit any reserve, you see towers everywhere. It's because, you know, I don't think a lot of people will even notice, because they're not really, that's not what they're looking at when they come into your reserve.
If I can prove that point. Has anybody in the audience that comes from South Africa seen a difference in every house in Kenya when it comes to their television systems? Okay, so when you're driving back, have a look at the angle of the dishes. It's pointing almost straight up. It's because of where we are, very close to the equator. But it just shows you drive past how many of those, and none of you saw the fact that the dish is sitting like that. So it's actually irrelevant. People that's tuned to it actually look for it.
More questions from your side? Otherwise, we'll just have another one here. No, we actually have been talking about that quite a lot. Any challenges that we haven't mentioned, Rian?
I think we skimmed over the maintenance side of things, and it might be worthwhile, to look at that. So, I mean, we called out the importance of identifying the relevant sites and that type of thing, keeping height, acceptable, all those type of things. But it does happen sometimes that you're in topology and you do have to get that mast right there, on a copy where you've got to chopper it in and that type of thing. That means that you cannot get to that mast, on a routine basis. So you need to, if you deploy something like that, make sure that you do equip that specific position, and for that matter, you can do it with everything. Sean, you mentioned it yesterday, is make sure that you can actually monitor the health of the installation remotely. And if I say remotely, I'm not talking about somebody sitting in Joburg, Bangalore, that type of thing. I'm talking about your IT custodian on premise can, on a daily basis, see what's the power draw on my power solution that's sitting at that. What's the heat in my enclosures? Because that way, you can plan your maintenance. You can see when the batteries are starting to degrade, okay? And you can plan for the next visit that a chopper is going over. Make sure that that is part and parcel of my plan, to go and visit that site, to fix the problem, and move on. And having that remote eyes on it, you know exactly what to take with. Because in this topology game, it is, if you can visit a fault, best you have the relevant things to fix that fault. Because otherwise it's a waste of time, it's a waste of money.
I'll add to that and also criticise myself. I got a bit of a telling off yesterday from one of my customers, friends, client, whatever you want to call them, or call each other's relationship. And that was down to IoT. The point is, there were sensors on that repeater site, okay, that I didn't spot that was down. Because I've got another 30 other sites, and sometimes you miss a piece of data, which is why for me, it's so important, as you just mentioned, is you become the champions with inside your own ops rooms. It's very cheap and very simple to put a sensor on a repeater onto power, and you can monitor that, okay? So many years, I'd say, what, eight, 9 years ago when we started building radio infrastructures, they'd only last about 2 years. And we were always, you see donor fatigue. Why do radio infrastructures only last 2 years? I've got one with military clients that have been going for 15 years because they have maintenance contracts, okay? And then the return of investment of that maintenance contract tenfold, because those radios you don't have to buy again because you get licenses and you get all this sort of stuff, you upgrade and stuff. But the most powerful thing we ever did in step change, apart from obviously training, was IoT sensors on your systems, exactly what you just mentioned, so you can see what the power's doing on that site. If you know what the power's doing, then you know what the radio's doing. And with the Victrons, for example, and that's just one product, you connect those to your solar panels, to your batteries, and they even tell you what the weather's doing. They tell you what the temperature is. So you can then gauge what the weather's doing, you know what, if it's a cloudy day, you know what the power's doing, you can see the solar yield, you know exactly what the solar's doing, so you know what the batteries are doing, so you know what the radios are doing. And that means the radio's zero downtime, which, back in the day, you'd get a phone call and you'd say, hey, your radios don't work. Okay, when they break down? Oh, 3 months ago. 3 months ago, your radio's broke. Wow, what you want to be doing is, my radio's broke 10 minutes ago, and you're saying, yeah, I know, I'm monitoring it. But you need to monitor it, because if you rely on the suppliers sometimes, they may miss it. And this is transferring of skills of what we've got to you, and that includes the tools as well. That's the most important thing for me, is really, I haven't deployed in 2.5 years, because our Kenyan engineers do all the deployment. But before that, we were deploying all the time, fixing stuff. We don't do that anymore, because the teams that we're working with, we've got IoT, sensors on their systems, they maintain and manage their system. Return on investment is huge, because you're not buying a radio infrastructure every 3 or 4 years. You're keeping the same infrastructure every 10 and even longer. So it's really important that these sensors are put in. They're not very expensive, and it's a game changer for your topology and your infrastructure.
Yeah, I mean, in that sense, it sounds really geeky, but you would want your control room people to actually almost have a relationship with these sensors. Because basically, if you see what that MPPT is doing, right, when is it going to float, when is it going to absorption, you know what time of the year it is, so you know, okay, it should be going to absorption around 11, and we've had sites where you can see that slowly, that absorption is going up, and without, you know, just looking at some graphs, you can then just tell these guys in Liwonde was like, there's probably a tree that's now growing over your system, maybe you should go there and cut it, and that's then exactly it, right? But we, as me and Jeff and other people who support that, we can't do that for 20 parks. But people on the ground should then have that knowledge. You know, they should check that system every morning, every afternoon, see what's happening, get a feeling of what's happening on the ground.
I'll give you a planning example of that, okay? So there's a poaching incident, channel 3 is the repeater channel, right? Everyone's now on that radio channel and your power is down. So the batteries are now draining, okay? Let's say you see the batteries are draining, you can make a command decision in the ops room and say, right, we need to get everyone off channel 3 because it's killing the batteries, it's killing the repeater. So you can now say, right, patrol channel 1, simplex channel, okay, radio to radio. And then you use your operation on that simplex channel whilst your batteries are recharging because obviously you've got a bit of an issue. So having those sensors allows the command team from the command center to actually change the way you do your operations whilst you're maintaining your power. So that's the importance of understanding what your power is doing because you can actually change your operation output.
Yeah, so we often, I mean, you guys keep mentioning the people on the ground must monitor it and people on the ground must monitor it. And it's so easy to say that. And it's so hard to train the people on the ground is to understand the LoRaWAN system, understand how camera traps work, understand how the radio network works, network links go down. And we are battling with finding those people and providing proper training for them. Because I know it's your frustration too. You know, people would phone and say, well, just go to the tower and go and check them. Well, what the hell must I check? I'm not sure. You know, it all looks blue and I don't know what's, you know, and I think that's what we're grappling with. You know, we're building different networks and I say, well, you just, you know, get a field ranger and just go and I'll train you up a little bit and we just leave you. It doesn't work. So, I don't know if anyone has actually the answer, but we do need training on various items, and I think it's becoming more and more obvious. And it's not the high-level training like you guys have, it's the in-the-park basic management of going to fix a tower. Is there anything available?
It's an absolute valid point. And with that, you need to throw the retention of those skills in, because as soon as you train somebody up, you know, they tend to disappear. Okay. So let me tackle the retention one first, and then we'll get to the other one. So from a retention point of view, what we've been talking about is removing this mundane checking of stuff from your IT resource or your is absolutely important, because you then free them up to actually grow and, you know, add value to the operation, because otherwise they're just a lackey. They're somebody that spends 90% of their time in a vehicle driving from high site to a high site with a clipboard writing down, you know, what is broken, what's the temperature, that type of thing. From a training point of view, I know there's a few initiatives, you know, where people are putting technical training together as part of this, but in our experience as CCF, it is hugely important to have that local tech-savvy resource and train them up on the equipment or the deployment that's relevant to their environment. And as you augment the technology, part and parcel of that implementation is a knowledge sharing, a training type thing. But with that said, it is, again, very important for that technical lead to convert information shared into knowledge. Because another thing that we struggle with is scaling. You know, there's so many people that we can help that we can't constantly be on recce's or be on site to support. So whenever we sit and we speak to the technical owners on site, the onus is on us to share knowledge that is pertinent to that installation. But there's also an onus on the people that gets the information to convert that information into knowledge. At this stage, I'm not aware, Sophie, and I'm going to look at you. Are you aware of anything fixed as yet?
Yeah, just to answer, so the guys have done that training. It's just that that's just one aspect of the number of training. And it would be great just to go over one-stop shop for everything that's happening in the reserve that you can send people to that can have a basic level of training.
I'm going to just put this question back to someone I served in the military with who actually did a presentation yesterday, which was absolutely fantastic, which was on operation rooms, which if you did see it, Swabia would just drop a line on this reference training and ops room management, because ultimately that's where all this is done.
What I was going to say is it's a very valid point. And even if you do send them on a Cisco course or whatever course, you know, Ubiquity, whatever it is, that retention is really difficult because now they have a skill and they can go to the local town and get recruited by a telecom, you know, because I now know Cisco, I know Ubiquity, I now know 4G, 3G, whatever. So what we're trying to do is create an application which is basically a fault-finding playbook, as Rian calls it. So the guys can go to site and just follow the steps, right? Yes, no, yes, no, yes, no, yes, no. That allows me now to sit in my office and go, right, I know what the issue is, right? And that's all we need. Somebody to go to site and tell me this is on, this is off, this is on, this is off, you know. And I can normally tell what the issue is, or I know what to come to site with to check or replace. So something like that, very easy, very deployable, you know, on a PDA, yes, no, send, and the person in the office knows exactly what they need to do.
So just to put in my 2 cents as well, I mean, that's my job, right, at Africa Park, for which I'm working with my colleagues on the ground to try and keep everything up and running, right? And one of the things when I did start my position a couple of years ago is just realizing how much stuff is out there. So as an organization, as Beach Parks, if you go towards a system or if you go towards whatever you want to do, I do think it's really important to at some stage make a decision as to what you're going to use and standardize. We are 50% by now, and it took us 2 years to get there, but it will mean that whenever you go to a random park, if you have a repeater tower, your power solution is A, your batteries are this, it's all the same, right? If you have just a hop tower or a LoRa tower, your power solution is this. And it took us all that time to do standardize that, but that does mean that I can now start making diagrams, training materials. We've already got some really good people in Rwanda. When South Sudan comes, we can hopefully send those guys there. We're going to Kafue in another 2 weeks. And we can actually start asking our tech people from the ground, join us please, because if you already have a system that is working, when you come into a park as a technology person, it's hard to learn, you know, what's happening. It's actually quite nice to be able to be at an installation, because it will, you learn a lot because of the installation. And we obviously have that luxury, which I know is not for everyone. But yeah, training is definitely key. And one thing I do want to mention is, which I'm struggling with sometimes with people moving away, and something we cannot help is laws in countries where people can just say on Monday, I've got a new job, I'm gone, and by Tuesday they're gone. So handover is a huge problem in what we do, and yeah, so that is a challenge for us. What we do sometimes see is that people put a lot of money towards installing a radio system, but they forget about the part where you actually need to train someone to maintain that system or to have a control room personnel. Yeah.
The other thing that you should also consider is, because I came out of a where I always had I had repeaters, and I always had a mobile repeater. If I had an issue, I put it in an aircraft and I dispatched the aircraft, and he went over. If I was in an area in operations where I needed a Telstar, I worked with that. It was always a spare repeater. Something happened, I dispatched it and put it on a high point. Either an aircraft, and I mean, if you African parks are you big, you can afford to have a Husky available. That's the level we've got.
Jeff?
Okay, so Yuri actually stole 90%, not stole, but said 90% of what I wanted to say. But Clay, to answer your question, I think that we are privileged to be able to install them and then watch the kind of how these systems evolve and how they break over time, which they do. And I think that we often reflect back on what we did as actually the problem as the installer, not necessarily the people in the park. So, we like, a site will go down and we'll think about it, we're like, yeah, actually we rushed that one. It was getting dark, the area wasn't safe, and we left too soon, right? So, it comes down to, you can make the person fixing or the person who's going to fix that site's job as easy as possible. So it comes down to even a cable that's 1 meter long, each end is labeled with which end it goes in, which plug it in. Every plug is labeled. The green cables have power and data. The blue cables only have data. And it means that the person who approaches that situation, they're probably nervous because it's not their world. I'm happy to unplug anything and blow anything up because I can apologize and I also know what I'm doing. But these guys don't. So they panic when they're sitting in front of something that they don't understand how it works. So if you take them through like a very step-by-step guide where they can see everything's labeled, you generally tend to get people who can work at a level that is more experienced than they actually are at that point. And that really comes down to budget twice as much time on the site as you need. And it must be a foolproof. Everything has been in the same place, is what he said. Everything is standardized. Every component is the same place. Every pipper key is labeled, and that allows people at a way lower level to get things done.
Can I just add to that as well? If you do stuff like that, then you'll have the perfect part, because actually you're not wasting money on all the other rubbish that goes wrong. And then obviously, then you can afford the sensors. When you choose your radio, you might not want to get, you might not need the most expensive one. You can get the lower model. And if you buy 20 of the lower model, you can afford the sensors. So actually, you can budget. And then if you deploy them properly, like you just said, Jeff, then you're saving yourself a lot of money. You can use that money on the training or the support.
And training is part of the project. It's not done unless somebody on the site can fix a problem quickly. And IT and the business side of things, if you have a look at the corporate world, it's exactly the same pressures that you said. The operational team does not give a flying hoot what is wrong. Fix it. You've got a young IT guy that's sitting in front of all of these flashing lights, and he doesn't have a playbook. He's not going to reach those targets to get the system up.
So something that's really important and often overlooked is preventative maintenance. Go and clean your solar panels. Honestly, go and clean your solar panels, because dirty panels degrading your batteries, degrading your whole system. Yeah, very common problem. You'll go there, this tree's overgrown, the panel is completely grungy, and they wonder why the system fell over. And you're just like...
And that comes down to something that is overlooked, and then we'll go to the next one as well, which what we started with is responsibility. Because, Jeff and myself, because we're trying to make sure that the people know everything before we leave, we do plan for training all the time. We've got a 1 week radio installation at a point, and we're going for 3 weeks because we want 2 weeks to train the people. You get there, tower's not done. Mounts are not correct. You're running around, installing everything, and I've got examples where we literally had 2 hours left before we left the park that we actually finished something that we were planning to finish in 5 days, right? And that comes down to responsibilities on the ground about building these towers, making sure it's finished, making sure it's correct. And that's definitely, and speaking from our side now, that's definitely not something that a provider can do. Taking your responsibility is something that you have to do at the park level, and you can't say, hey guys, you install a radio system, but it's wrong because the antenna is pointing up. There's responsibilities that we do need to do. Did you have a comment there, or the microphone's there?
I'm curious if you all have experience with remote restart hardware or automated reset systems, and if that has a positive impact, and if so, what percentage of decreased service escalations are you seeing from that sort of thing?
So power-wise, personally, we don't really do the remote, but definitely in all the switches and stuff. So anything that is in the network, LoRa systems, all of that stuff can be reset by logging into the switch, give it a power reboot, and often it will come back. When I started Akagera, that wasn't possible, so I would have to drive to the tower, take UTP cable out, wait 10 seconds, put it back in. But now I can do that from the Netherlands. I'm sure you guys use it, but I'm not sure in Power Solutions.
No, not Power Solutions. I mean, if I have a look at our approach to Power Solutions, typically monitored within the reserve itself, so it becomes a operational situation to go and rectify. But I think, Eric, the early warning is where, you know, where the focus is monitor it. If you see it starting to, you know, the service to degrade, you know, put it into the next patrol that goes past, or that type of thing. Make sure that the relevant skilled person, and not the ranger, yeah, the relevant skilled person. It's the same as the operating room. Don't grab a ranger and put him in the operating room. Yeah, make sure it's part of your planning, but make sure you've got the visibility. If we have a look at the rest of the things, the networks, the point-to-point, point-to-multipoint, LoRa, all those type of things, what we do is we actually apply normal enterprise IT type approach to it. So we've got remote monitoring on a daily basis. You know, we actually VPN, and sorry if I go too technical, but we VPN into the reserve area networks. We monitor all the IP endpoints for availability and those type of things. If we do see that traffic is only traversing the network in one area, we'll actually notify the on-site technical people that we're seeing all the radios, but you know, for some other reason, the traffic is only flowing one way around. We're not seeing a link being up and that type of thing. So that kind of proactive monitoring is there, but Power Solution is absolutely on-prem type thing.
Okay, so yeah, I think to answer, thanks for answering that question I asked, but I think what is quite clear is what Jeff has said. We can make it easier by labeling cables. We can make it easier by, you know, doing everything, trying to manage it remotely. I think there's still a shortage of actually having a training course, because that's something we're grappling with. And you know, we are taking Cisco, taking, you know, we don't need so technical information. They don't necessarily have to go on that course. Is there anyone in this room who is keen to work together and looking at training people on the ground? I mean, you just mentioned that you're in a hurry, you leave, and you haven't trained that person 100%. And I think that's the key thing. Or they leave, you know, after a couple of months, now they've got the training, they move to the next park. I think there's a real need, whether it's an online course.
I promised EarthRanger I wouldn't sell anything because I'm not allowed. But I do have an online training platform.
Woohoo.
And I am talking to the EarthRanger team, and maybe that might be something in the future. But an online training platform is very simple. They're out there, and you can put your own content on that, which is what I'm doing. And the point of it is, when you log in, you can see who's logging in and how long they're on for, then you can basically get them trained up and give them certificates. We all love certificates, right? So they do exist. So even if you never hear from me again, there are online training platforms. Reach out to a company, and they will happily put content on there for you.
Yeah, Jeff, if I can link up there, I think if we can gain an understanding of what the typical landscape, technology landscape look like, you know, that people are working in, then we can understand who in the industry or who that we speak to might already have a playbook. I mean, Swabir was referring to it, the LoRa network that we helping, you know, roll out and that type of thing. There's playbooks being created for that. And I don't see any reason why, if we've got a playbook for a Cisco-based LoRa deployment, why that cannot be shared with the industry, and you then just tailor it, because unfortunately there will be some tailoring to the local park, you know, to make it relevant, to say, okay, this thing speaks to that thing. So in my mind, I mean, that would be one of the suggestions. Yeah, let's understand what the ask is, and let's see where we can go and find things that already exist and start to drive that together.
If you don't ask, you don't get. I think, and a lot of people are so busy doing stuff that if you don't ask for it and say, hey, do you do an online training course? And I guarantee you, there's so many people here that probably do one or got one or no access to one. So I think one for EarthRanger, you know, if you don't ask, sometimes if you don't know, it's your problem, and it's down to budgets as well.
So I think you admit from our side, online training, no, we don't have it yet. Anything in terms of what we're using, yes, we're willing to share everything. I mean, there's no problem, just talk to me, talk to Jeff. We can do that. Thank you guys for joining us.